11 Advanced 3.2 Work and Power MCQ only. Which of the following is a correct definition of work? So basically the work is a product of the force and the distance moved in the same direction. Question 2. A student makes three statements about there is no work. When there is no work, it's only when the object is moving with a uniform circular motion, because in this case the velocity will be perpendicular to the direction of the acceleration. So this means that the motion and the force is perpendicular to the displacement. So basically it's only one, so option A. Question 3. The figure below shows four forces on a book placed on a table. The book moves to the right at a constant speed. Which of the forces do not work? So basically, the object is moving, so that is the displacement. The force that are perpendicular, which is the normal and the gravity, they do no work. So basically, the normal and the gravity. Question number 4. You have a force of 5 acts over a distance of 12 in the direction of the force. So basically theta here is equal to 0 degrees because the force and the displacement are in the same direction. The work is force by displacement by cosine here of 0. So you have 12 by 5 by 1, which will give me 60 joules. Number 5, you pull a sled with a rope, which makes an angle of 30 to the horizontal, and the tension in the rope is 40 Newton. So that is the tension, and here you have 30 degrees, and it moves a distance of 100. So basically the work is equal to the force by the distance by cosine of 30, giving me a 300 or 3000. So it's gonna be cosine of 30 by 100 by 40. So it's gonna be a 3480, which is almost, this is in joules, so in kilojoules it is 3.48 or 46. Question number 6. You have a boy that pushes a box across the floor. The boy pushes the box a distance of 13. His applied force makes an angle of 160 Newton, makes an angle of 30 with the floor. What's the amount of work done? The same thing. So the work is equal to force by distance by cosine of 30. So the answer is here 1800, 160 by 13 by cosine of 30, this much. Now question 7, we have a boy that pushes a crate of 35 kilograms across a horizontal floor with a force of 250 Newton. However, you have the coefficient of kinetic friction. So basically also I have a force of friction, which I don't know. The mu k equals to 0.3. I need to know how far does the crate move if the net work is equal to 2400 joules. So basically this work should be equal to F net by the distance, which I have, I don't know, by cosine of the angle. Let me first find F net. What is F net? I know that forward I have 250, but I don't know the force of friction. However, the force of the kinetic friction equals to mu normal. And mu here, the normal is equal to mg. I do have that the normal equals to the force of gravity, so it is 0.3 by 35 by 9.8 or 10, which gives me around 100. So it is 9.8 by 0.3 by 35, so it's gonna be almost 103. So F net equals to 250. So here on the side, F net equals to 250 minus this 103. Okay, so I'm gonna have F net equals to 147 in the direction of the largest force. So basically here cosine of theta, here the theta equals to 0, because the 147 is also to the right. So given 2400, F net equals to 147. Again, 147 is 250 minus the friction 103. The distance I don't know. By cosine of 0, I will have 2400 divided by 147. So I have 16 meters, 16.3. That was not very direct. However, questions 8, 9, and 10 are related. I have 10 kilogram block that is released from rest at the top of an inclined plane of height 2 meters, as shown in the figure below. You have the coefficient of kinetic friction between the block and the surface is 0.2. I need to first, in question number 8, I need to find the work done by gravity. In question number 9, I need to find the work done by friction. And finally, I need to know the work done by the normal. Now, starting with the easiest one, I will start with the normal that is firstly perpendicular to the displacement. As it is falling, so basically the friction is to the back, and also the gravity is vertical downward. So because the displacement is downward, so it is perpendicular to the normal, this gives me that the work done by the normal, here the force of friction by displacement, here cosine of 90, giving me 0 joules. That's the easiest one. Now let's go to the work of gravity. Going to the work of gravity, I see that the angle between gravity and the displacement is this angle. And this angle is not actually 30, it's actually the complementary to 30, which is 60. So the work of gravity equals to, the work of gravity equals to the force of gravity, which is mg, by the distance by cosine of 60. So here I have 10 by 10 by 2 by 0. The mass is 10, the height is 2. Now the distance is not 2 here. I see. The distance as well, I don't know. I know that the height is equal to 2. Now, how much is the distance? Let us check the distance first. That the height was 2, not the distance is 2. So, given this Pythagorean theorem, okay, so here you have 2, and here you have 30. I need to find, let's say, C. So, the distance, all of it. So I know that sine of 30 equals to opposite, which is 2 divided by C. So giving me that C equals to 4. C, which is actually the distance, and replacing here it by 4, and again cosine of 60 is 0.5, so it will give me 200 joules. So the correct answer is 200 joules. Now, going to the work done by the friction, we agreed that the work done by friction cannot be positive, and also it is not perpendicular. The force is not perpendicular to the distance. So the work of friction is actually the force of friction. The force of friction, sorry, here it is F normal. It is the force of friction by the distance by cosine of 180, because they are totally opposite to each other. Now the question here is, what if is the force of friction? I know that the distance is now 4 and cosine of 180 equals to -1. Now what is the force of friction? On the side, I know that the force of friction equals to mu normal. However, in this case, the normal equals to W cosine mg. Let's write it the way you know it. It is adjacent to the 30, so it is equal to mg cosine of theta. Now replacing the normal by mg cosine of 30, it will give me 0. So the kinetic mu 0.2 by 10 by 10 by cosine of 30, which is 0.87. I will have it equal to 17.4. Now let me replace it here. 17.4 times 4. I will have -68. Question number 11. You have so here we need to do a small correction for the answer key. The amount of force, I need to find it until 2 centimeters. So here I know that I have to find the area. Now let's find the area. The area is a triangle here, so half base times height. Not to forget that my displacement is in centimeters, so it is half by 20 by 20 by 10 to the power of -2. So I will have only 2 joules. So the correct answer is 2 joules, not 200. So number 12. So you have also a graph. You need to find the work until only 3 meters. So again, find the area. All right, so the area here is also half base times height, which will give me 1/2, 45 by 3. The answer is 68. How much power it will be developed in if the work here is done in 2.5 seconds, given the work over the time. So 68 divided by 2.5, this 68, it will give me 27 watt. Question number 14, we have 50-gram bullet initially at rest and it is fired from a gun at a speed of 20. What's the amount of work done? So the work is the change in kinetic energy. So it is half mv final squared minus half mv initial squared. But here it started from rest, and not to forget that the mass should be divided by 1000, so 0.05. Okay, by computing everything by its value, I will have 2000 joules, which is 2 kilojoules. Number 15, you have a chemical energy stored in a particular rocket and is able to do 800 kilojoules of work on the 250 kilogram rocket when released. What's the maximum possible speed? So also starting from rest, so the work is the change in kinetic energy. So basically, firstly, this rocket will not be moving and it will be given a final velocity, maximum velocity. Not to forget that our 800 will have 3 more zeros and half the mass is 250. It's okay in kilograms. I need to figure out the velocity, which will be 80. Question number 16. Also here we have a correction. It's not 100,000. What's the net work required to accelerate a 1000 car from 20 to 30 meters per second? The work is the change of kinetic energy, and by replacing everything by its value, all the numbers are okay. I will have 250,000 joules. Question number 17, which is true about the unit of the power. I know that the power equals to the work divided by the time. So it is joules per second, or I also call it the watt. So watt is okay. Joules per second is okay. Newton meter is not for power. Newton meter, I don't know if you remember, it was for torque. So basically, I only agree with 1 and 2. A box of weight W is moved at a constant velocity V. What's the power? The power, by definition, for constant speed is equal to the force by this constant speed. So it is this one. Number 19, I have a car traveling at a constant velocity. I do have the distance, I do have the time, I do have the force. No need to convert here the force because already my powers are in kilowatt. So it is the work divided by the time, and eventually the work is F by T over time, and the correct answer will be 30 kilowatt by replacing F by 1.5, D by 10, and T, the time, by 5. Number 20, you have a student that is of weight 600 Newton, climbs a vertical ladder, tall in time of 8. What's the power developed by the student against gravity? So the power is actually the work done by gravity So his force means the weight, and so the force is mg, that's the force, and d divided by the time. The correct answer is, so let's do it here. However, yeah, mg is all 600, no need to multiply by 10, so it's already the 600 given in Newton, by 6 divided by 8, which will give me 450. What? And that's it for the MCQs.